Hello, in this video I'm going to show you how to calculate your trig ratios. Now that you know a little bit about trig ratios and what they are, it's important that we learn to calculate them correctly. So what I've got set out here is a whole series of little calculations for you to do. In this first one here, I've just worked out what the sine of 30 degrees is. And in this one here, doing the inverse of that. So here we've got a ratio of 0.5, so we're going sine to the -1, find out how many degrees that is. And we're going to up the ante a little bit here. We've got 16 degrees 15 minutes. So how do we deal with that? We know that 15 minutes is a quarter of a degree, so we can sort that through as we're going. One of the famous comments I've heard, I don't know who it's attributed to, is never ask a question that you don't know the answer to. And in this case here, I'm applying that full noise so that you can see what the answer is. I know what the answer is to this particular one here, so I can check that it is correct. And then I'm going to do the inverse of that to check that I'm getting back to where I started again, and I'm going to do a lot of that. I call it deconstruction. I like to just pull everything apart and put it back together again, and that's particularly what I'm going to do with this triangle here. By the time we've finished with this triangle, there's nothing about it that you won't know, or that we won't know, or that we can't work out, or we don't know how to work out. So it's pulling things apart and seeing how they fit back together again. So what I'd like you to do now is to just stop this video and use your calculator or whatever tools you have available, and I would like you to just try and work out the answers to what I've got there on the screen. Have a go yourself. Don't be at all afraid to get it wrong. There's no problem with getting it wrong. Just have a go and see what you get, and then when you've done the best you can, or you think you've got it all sorted, I'd like you to start the video again, and when you start the video again, you will find that the answers are there, and we'll go through those answers with you using this calculator here. Now this calculator here is the HP 15C. It was one of the cheaper calculators that was used by surveyors in the earlier days. It has a small programming capability to it, and we did have a few programs that we could load into it that a lot of surveyors would use out in the field. One of the beauties of it is that it has the ability to accept information in this HMS format, which in this case here is hours, minutes and seconds, or it could equally be degrees, minutes and seconds. Given that there's 60 minutes in a degree, 60 seconds in a minute. Just the same with time as it is with degrees. This particular one I've downloaded from the net. It's free. It's the HP 15C emulator. I've also downloaded another small piece of software called Always on Top. Again, it's a freebie. What that does is make sure that the window that this calculator's in is always on top, so that it stays there to be used when other programs are operating underneath. So enough about that. Let's get the answers up here and let's start working through these problems. Alright, so here's the first one, sine 30 degrees. Well, let's see how we might do sine 30 degrees. Pretty simple really. I just got it cleared here. So 30 like so, and sine. And the sine 30 degrees is 0.5. I've shown it here to 4 decimal places. And I try to retain the decimal places or the calculation in there. I could show it, for instance, to 7 or 8 decimal places, I think is the maximum, by just pushing this function key here, fix 7, and there we have it to 7 decimal places. So, but let's just put it back to 4, so fix 4. You'll note that this calculator at the moment is in degree mode. We know that because it's not showing that it's in any other mode. if it was to be in, say, radians mode, you'll see that there's a little radians come up there. Or if it was in grads mode, the French system, where there's 400 degrees in a circle and 100 grads, as it is, or grads in a right angle, 400 grads in a circle. But no, we're going to have it in degree mode, because that's how we roll. So I'll just put this back into degree mode here. Now, there's our 0.5, and of course, one would hope that if we did the inverse, sine to the negative 1, 0.5, we would get 30 degrees. So let's just confirm that, sine to the negative 1, and here it is, 30 degrees. So when we're working with equal, like a round or integer numbers of degrees, don't have too much problems. But here we are, we've got cos 16 degrees 15 minutes. Now I know that 15 minutes is a quarter of a degree, or 0.25. But when we see come down here, I can't do that one off the top of my head. So I need a piece of a tool that can do that for me. So this is how it does it in this calculator. Not all calculators are the same. So let's go 16.15, and then we use this little function here, to hours, or to hours and decimals. 16.25. Well, that sort of fits with what I thought the answer would be. And then let's find the cos of that, and yep, sure enough, I've got that one right. It's 3 out of 3 so far, 0.9600. Now, if we do the inverse though, how's that going to work? So let's do the inverse of that here. So cos to the negative 1, and we get 16.25, but that's degrees. We started off with it in this format, and that's where this to the HMS, or to hours, minutes and seconds, or degrees, minutes and seconds. Hours and degrees are the same in the sense that they're both split into minutes and seconds. So push this little button here, and there we are, 16 degrees 15 minutes, 0 seconds. So that's all very good. Okay, now it gets a little more complicated with this one here. 36 degrees 27 minutes and 25 seconds. Let's convert that to hours, or to decimal degrees, and then let's take the tan of that, and we get 0.7388. Well, very good. Let's check out the inverse, and just as I did with the other ones, again, always know the answer, what the answer is going to be. So we would expect the answer to be 36, 27, 25. So here we go with the inverse tan, and of course we get 36.4569, not quite what we expected, but we know that's in hours, so we have to convert that to hours, minutes and seconds. 36 degrees 27, 25. Bang on the money. Okay, so now I put up this little triangle here for you, which I said we were going to pull apart and put back together again, basically. So it's got a little angle in here of 28 degrees 1430, and the hypotenuse here of 143.62. So to find the opposite side, just use the sine there. So let's have a look at that. Sine. Oh, I didn't mean to do that. I probably should have cleared everything. So let's just clear everything. And of course we go 28.114 minutes and 30 seconds. So we need to get that into decimals of an hour, and then we're going to take the sine of that, and then we're going to, now this calculator is in reverse Polish notation, so that there can be entered into one of the registers, and then we can just put in 143.62 and times 67.9598. Now normally we would round that to 2 decimal places. Sorry, that was 67.9598, so that would be 67.96. I've left it in 4 decimal places because I want to use it going back the other way, which you'll see a little bit later on. So now we use the cosine function, and that will, or ratio, it is a function and a ratio. We'll use the cosine ratio to work out this little distance here using this little calculation here. So there are various things here that we may be able to use. I'm not so sure. Well, we could see what's in the xy. No, that's not going to be any use to us. There is one, and I'm just struggling to find it at the moment. One little function that's quite handy to use that I have seen on these calculators before, but it doesn't seem to be jumping out at me at this point in time. It's the one called the last x, where you could, oh, there it is on the enter key on the blue. So if we push blue last x, we get, there it is, the 143.62. So there won't be any need to re-enter that. We can go straight to put our cosine it is, so 28.1430. Again, there's memories and things in here that we could be using. 2 hours cosine, and that'll be times, and that'll give us 126.5234. Alright, so let's just do an xy here. No good there. So 126.5234, and that's what we get there. So that's that side there, and our answer's there. So now we can see that I've just put these two numbers in here in an attempt to do tan to the -1 to try and get this answer out here. Just note that I have not retained all the decimals here. I was hoping that I would have that in the x, and if I had done it another way I could have. So we've got the 126.5234. Let's just push enter, which will flick that in, and if you go xy, you'll see that it's in both in x and y. So now we can go 67.9598. So there it is, 67.9598. xy 126.5234, and all its decimals, I might add. And so then if we just push divide there, and then take the tan to the -1 of that, we get 28.2417, which is our decimals of an hour, or decimals of a degree. So we want that in hours, minutes and seconds, and this might, oh, that's come out alright, 28 degrees 1430. It is possible that it could have had a not quite right there. So there we go. Got back to there. Now the other little thing, of course, this is a right angle triangle. So this being the right angle here, 90-degree angle. So we know that this angle plus this angle equals 90. So what I've done here is just subtracted 28, 14, 30 from 90. We could, I've done that in my head there, but we could equally just do that here using the calculator, which you should use your head from time to time. So there's 90 degrees there, and then we would go 28.1430, but we would need to convert that to decimals of a degree to do this calculation, like so, and then we could take it away, and then we would have to convert this one back to that other format, HMS. So there you go, 61.4530. So the old noggin's still working. I did that in my head actually, and then just realized when I was going through the video that I could do it on the calculator. So there you go. Now I just wanted to show over here how we could equally calculate these sines from there. So obviously this here will be the opposite. We've already got it in there. So let's just convert that to hours, and I'll just push enter a couple of times, which will put it in there. So let's take sine, and then 143.62 times 126.5234. It's all good. It's there near agreeing. Let's do our xy. Oh, there's our 61.45 and just 30. So that's it in hours. So the next one we wanted to do on that was cos, and I wonder if our last x will be going here. No. So I'll just do the xy. That's our cosine, and 143.62. Just just check that's right, 143.62 times, it's 67.9598. So there we are, we've sort of worked the triangle using every possible one there. And let's not forget our dear old friend Pythagoras. We know that the square on the hypotenuse is equal to the sum of the squares of the other two sides in a right angle triangle. So let's see how we could perhaps go about doing that in the calculator. 67.9598 there, and that's the one we want there. So let's just use our little x squared button that we've got here, and let's key in 126.5234. Let's just square that. We'll use the x squared button. Let's add those two together and take the square root, and lo and behold, 143.62. Very good. We've got it. Nailed it. So there you are. There you are. You have some a little calculator that you might want to download. It's one that's been well served in the survey industry. Quite a calculator that has been used a lot in the past. There are more up-to-date and more fanciful models than that, but that's quite a nice simple one, quite easily downloaded on the internet. Don't forget the always on top, which makes it quite helpful. And then some examples here that you've gone through. So if you're having another calculator that you're using, perhaps a different type of calculator, you might like to use these same questions and the answers here, and go through and just make sure that you've got all your calculator routines and your understanding of your calculator is working correctly, because these are the answers that you should get. So this is a very useful little exercise to do before you move on with trig ratios, just to make sure that you're calculating everything correctly. So all good.